Okay, we finished lecture 3 yesterday. Huh? You're saying something? Huh? We finished lecture 3 yesterday, which was about traffic flow parameters and traffic flow theory. Okay. So, how many types of traffic flow parameters we have? 3. 2. Which 2? Micro and macro. Okay. What are the macroscopic parameters? Density, speed, volume. Any speed? SMS? Average speed. Okay. And average speed can be SMS or TMS. Okay. Microscopic parameters. Head weight, spacing, speed. Again, which is speed then? Individual speed. Okay. So, and then what we discussed in the end was the situation, the concepts of demand, capacity, and volume. Okay. So demand changes time to time, which changes volume, and capacity depends upon design of the route. Okay. And then we looked at some problems. If demand goes over capacity, what are we trying to find out? What are the important things for us? We're going to start with lecture 4, which is from chapter 9. And in this lecture, we are starting the other part of the course, you can say, which is about traffic data collection. Okay. And the first part of the course was these basics. Systems of traffic flow, components of traffic system, traffic parameters, geometric design. Okay. Now we are starting the second part, which is about traffic data collection and reduction. Reduction means analyzing traffic data to find out important parameters from it. Very quick and easy example is speed. So you have a speed of 100 vehicles. How do you reduce it? You have a speed of 100 vehicles. How do you reduce it into one value? You take average. Okay, so this is part of reduction. Okay, traffic data is collected to know the current state of the system. How much traffic we are having, how much delay we are having, the signal timings, okay, what type of vehicles we have, and so on and so forth. The demand on the system. I mentioned yesterday, or maybe before that, what you see on the highway may not be the actual demand. Why? Because it exceeded capacity, so what happened then? Yeah. In certain situations, those people may not be on the highway, which are part of the demand. Okay. Because of the jam, because of the breakdown, those people may have gone from some other way, some other time. Okay. They have avoided their trip. So the current demand and future projections. So if I ask you what will be traffic after 20 years, so you need the traffic, yeah. Okay, then you need the, if I ask you for future projections, what will happen after 20 years? What do you need? Daily volume? How do you calculate for future? Multiply by a factor. Who would give you this factor? Or how do you get this factor? From last year to the previous years. What was the growth rate in the previous years? Okay, so again you need the data, multiple times of data. Okay, before you start collecting the data, you should know where and how you are going to use it. For example, in your term project, I am guiding you, right? I'm telling you what to collect and how to collect and when to collect. Okay, some of you came to me that we want to start collecting the data for the second submission. Okay, and I told them you don't know what to collect it. You need to wait. Okay, I can give you an idea, but still, you may collect it, and then I would say that it's wrong. Okay, I'll give one example that some of the students in the senior design project, they collected some data, they came to me, and like I have to reject half of their data because this is not what we wanted. So they collected like 200 values, and only 100 values were useful. So the other 100 were useless. They wasted their time and effort. Okay, so before you start collecting the data, you should know what I'm going to do in the end with the data. Okay, as we just said, we want to forecast traffic for the next 20 years. So is 2 days of data enough? And he said for next 20 years, I will forecast what? Daily volume. So instead of daily volume, give me hourly volume. You waste 20 hours in the field for collecting data, and then you come to me or you come to the consultant and he says this is not enough or this is not what I want. Okay, so your effort and time is wasted. Okay, so whenever you deal with field data collection for anything, not only for traffic, but going in the field, even for a simple surveying task, all of you have done surveying, right? A long time ago, right? So even for a simple surveying task where you have to go and just measure the distance or take the elevations, you need equipment, you need people, okay, and the equipment should be in a working condition. You should know from where you have to collect the data and so on. So you have to plan before you go and start working in the field. You should plan. Okay, so this is what they are talking about. So this applies to all types of field data. We don't want to waste our effort in the field. We may invest half an hour more in the office instead of wasting 15-20 minutes in the field, because those 15-20 minutes are costing me more instead of half an hour in the office. Okay, so now when we earlier traditionally or classically or right now, even now, if I ask you for traffic data, what comes to your mind? I'm asking you to collect data about what? The speed of what? Vehicles. Okay, so this is the classical purview or the classical concept of traffic data. It is about vehicles. Okay, this is only now in current situation, this is only a part of it. Okay, now you start or you must be hearing a lot of things about sustainability, reducing environmental emissions, and so on and so forth. So traffic and transportation engineers and planners also have to consider these things. If you just focus on vehicles, you're not going to achieve your sustainability and environmental emission goals. Okay, so you have to include multiple modes of transport. The vehicle is one way of traveling. Vehicles are one way of traveling. The other way is what are the other choices for traveling? Buses. Okay, fine. Metro. Okay. What else? Huh? Airplanes. Bicycles. Trains. Okay. And what else? Walking. So you, as a transportation engineer, you have to consider all these things now. Okay. Even walking and bicycling. Okay. And trains and so on. This all comes under traffic data now. Okay, yeah. So as a traffic engineer, you have to consider the exclusive dedicated spaces for multiple modes and shared spaces. Okay, for example, a bus. The buses in Bahrain don't have a dedicated lane, right? You talked about metro. Metro has its own right of way. Okay, so some spaces are shared and some spaces are dedicated. Okay, dedicated means they are exclusive. Only these can use it. Okay, so if you go to Zakhir, they have a bicycle lane as well. That is only for bicycles. In other areas, there is no lane for bicycles. So bicyclists and pedestrians and maybe vehicles, bicycles are on the street. Okay, so that is shared. Okay. So this also comes in your domain. This also comes in your area of expertise now. From where we can collect data, there are online databases available. Not for even for some of the Gulf countries, for some of the services, you may find online data available. For example, King Fahd Causeway. Okay, they have an authority and they publish data on daily basis. How many cars went from Bahrain to Saudi and how many cars come from Saudi to Bahrain, and even for trucks and buses and so on. Okay, so they publish the data. They have their own growth rates. Okay, so you can see yearly data as well. How much average traffic was there in 2020, 2021, and so on. Okay, and other countries they even publish the accident data. There was a seminar last year. Somebody came from Ministry of Works, I think. Anybody attended that? It was in that hall, right? Last year. So he was showing data from other countries. Which country? I don't remember. US, Australia, UK. These are the countries which have lots of data available online. Traffic data, accident data, and so on. And a graphical interface. So you click on the map and you can get to the data. Okay. So there are online databases available. Some of them are mentioned here. The two which I mentioned. The first one is for USA and the second one is for the King Fahd Causeway Authority. But Australia, UK, and some of the European countries, they have online databases which are open source. Okay, you can. One of my friends, he was doing some research in Saudi Arabia, and he used the data from 5 countries. Okay, accident data from 5 countries. And guess which country was not included? Obviously, Bahrain is not included. He's not in Bahrain, but he was where? Saudi. He said it's easier to get the data of these 5 countries, which are thousands of miles away, rather than having the data from Saudi Arabia. Okay, so and then we have data which is electronically generated every day. While you are moving, you have the location on in your phone, even if you are not using the navigation. The data is stored. Okay, and then there are places where the data is recorded for you. For example, mentioned King Fahd Causeway. So in other countries, they have these toll booths and checkposts. So whenever you are passing through them, they record your license plate number. So this electronic data is generated every day. Okay, whether somebody is using it for transportation planning or not, it is generated. It's a database which is already there. Okay, the database which is generated through your tracking applications, through your positioning applications, and so on. So yeah, in some countries they use tags. Like you have barcodes on products. They have these barcodes. They call them RFID, which is solid. Solid. Okay, maybe. Yeah, but they have this. They put a tag, and it's an RFID tag. The vehicle passes through a particular point. The sensor will read the tag instead of the license plate number. It reads the tag. Okay, and the tag is attached to you, like the driver. Okay, so they have to charge you for any tax or fine, or so on and so forth. Okay, so this is electronically generated data which is generated automatically and it's stored. Okay, you just need to get an access to use that data. So this data is not accessible to everybody. So the first category is open source. You click on these links, it will take you to your website which has the data. But this one, then you need special permissions. So there are companies which are holding this data. Then we have traditional approaches of collecting the data manually. Okay, so you can go to the field and use some type of counters. Okay, counters are, these are the counters. Okay, so we have a mini counter as well, which is just for one direction. This is a board counter, this one. The mini counter is hidden on the top. Okay, but again, they have like click buttons. So you are counting vehicles and you are clicking on the button and the counter is going on. So you click 5 times, it got 5 vehicles. Got it? Okay. So the first one, for example, you may not see the counter, but you can see the 5 buttons on the top, right? So at a time, you can use it to count 5 different types of vehicles. Each counter for one thing. Okay. In a board counter, you can use it on intersections. Okay. One side for each direction. Okay. So this side for the east side, this one for the west side, and so on. Okay. And again, you can, for each side, you have 4 or 5 different counters. Okay. So you can do it for each lane or each type of vehicle. I will count cars, you count trucks, so on and so forth. Okay. Then we have these apps which can be installed on tablets. Okay. So instead of a button which is showing you numbers, you have this program which is recording the data, but it's still you are the one who is prompting it. Okay. So car passes, you have to click. It's not automatic. Okay. The automatic counter which they use is what they call as a pneumatic road tube. So this is a pneumatic road tube. Okay, you cannot see it properly here, but it's used very commonly in Bahrain. Okay, they have these thin wires. Okay, which you will find in the middle of the road. Okay, so they are not there by accident. They use it for counting. So on the end of the wire, there's a counter. So when your car passes over the wire, they count your vehicles. So this is very common. Okay, so we call them where is it? Tubes, pneumatic road tubes. We will discuss it later on. No problem. Okay, so we talked about the counters, hand counters, the apps. Okay, then we have detectors. So now this is this one is automated. Okay, so side fire or radar detectors are those which are counting or which are installed on the side of the road. Okay, so we call them side fires because of their position. They are installed on the side of the road and the car passes in front of them, or the vehicle passes in front of them and the counter. Okay, then we have point detectors which are installed under the road. Okay, again very commonly used in Bahrain on signals especially. Okay, they have these counters under the surface of the pavement. Okay, so your car passes over them and it will count, but again automatically. Okay, and so the difference between a tube and a point detector is on a tube is over the surface, so you can put it and you can take it back, but the point detector is under the surface. Okay, so you install it once and then it will keep on running. Okay, and even side fire radar detectors we use very commonly, but on local level, especially in parking lots. They have these checkposts, the barriers. So barriers are normally operated through side fire. Okay, but they have in some cases the point detectors as well. Then we have video-based measurements. So you take a video. Anybody did that in the THUMB project? Somebody did, I think. You took a video and then you took the measurements from the video. You counted the vehicles from the video, measured the speed from the video. So you know that, okay? But they are saying the video should be from a good point that you don't miss anything. Okay, so you are taking the video like this, and there's a truck passing in front of you. Behind the truck, there may be, a bike or a car, so you will miss it. The video taken from a vantage point, a good point from where you can view that entire segment. Okay, and then we have, smartphones and other devices. These smartphones can be used for measurement, right? Again, we use them. Okay, but these smartphones are themselves data generators. There is data stored in them. Okay, in 2018, I think we did a senior design project in which we collected data. So we asked, these apps which you use for tracking your exercising and walking. So we use one of these apps to collect data about the users. Okay, so the app was recording how much distance they are traveling, what time and day and so on. So then you are getting the data from the app itself. Okay, so the phone is the data collection device itself. Okay, where can we use the data? Managing the system, the infrastructure of the transportation system. This system requires new projects, maintenance work. So how do we plan new projects and maintenance work for the transportation system? Through the data. Okay, so you see, for example, where are we doing any new construction on highways? Give me a place, give me a location. Al Fateh Highway, right? Why? Why there? Why not somewhere else? Because of traffic. So they must have collected some data, right? Get my point? So new projects are planned on the basis of the data which you have. Even maintenance work is planned according to the data which you have. The streets, they receive less maintenance, less frequent, okay, as compared to main highways and so on. Okay, so again, you need the data. Establishing time trends and predicting future, we already talked about that. If you want to predict what will happen in future, or you want to see what happened in the past, what was the trend, the growth factor and so on, you need the data. Understanding travel behavior, something related to us, not the counting of cars. Why we make a trip and how we are making a trip. So this is data about the travelers, us. Okay. So a particular person wants to go from place A to place B. Why he wants to go there and how he will like to go there. Would he like to use a bus? Okay. Or will he walk there, use a bicycle or a car, or what else? So obviously the decision is not that simple, right? When you say that person walked, there's a reason behind he's walking. Okay, maybe he cannot afford a car, maybe the place is too close, or maybe he is going there for exercise or something, so obviously he likes to walk and so on. Okay, so to know the reasons why he is making the trip and why he is selecting this approach for traveling. Okay, calibrating relationships between parameters. We did that in the last chapter. We derived equations between what? Flow density and speed. So this is what we call as calibrating the relationships. Okay, how flow affects speed, how speed affects density, and so on. Okay, so those, in order to drive these equations, what was the first thing we did? What was our starting point in the entire derivation process? From where did we start the derivations?
On the speed.
I'll give you a hint, it was a graph. We started from a graph. So the graph was between speed and density. Okay, so this is how we usually start. We collect some data, we plot it, we see how the relationship is, and then we know, if it's a linear line, we know the equation of a line. And start from that. Okay, so again, if you don't have the data, you don't know what the equation looks like. Okay, so assessing effectiveness, so they have mentioned some things here. So all the relationships which we derived in the previous chapter, we knew them on the basis of data. Okay, if you don't have the data, you don't know how and why these things are changing. Okay, assessing the effectiveness of improvements through follow-up studies. So, once they complete the construction of Al Fateh Highway, they will not just, close their eyes after that. They will monitor it. Even after completing the construction work, when it is reopened with the new design, they will again monitor it. So we call it a follow-up study. What happened after you did the new construction, the new design, the new maintenance, and so on? Okay. To see if my improvement was effective or not. I wanted to reduce the delay. I wanted to reduce the accidents. Did I do that? Did I do that or not? Okay. In some cases, you are hoping for good results, but the thing which you did, it backfired. Okay. In some cases, the accidents, instead of reducing, they increase, and so on and so forth. Okay, so these studies are very short because you know what you are looking for. I want to do at this place for this thing. I build this new intersection to reduce accidents. Let me see for one day, I will see if accidents are happening or not. So these studies are very simple, very short. Okay, potential impacts of new developments. Okay, and provide input for pollution models. Development means what? So you have a land, empty land, and somebody buys it, and then they use it for, let's say, a mall. So that mall is a development, a land development project. Okay, you have this Darul Muharram, right? The big project. So it's a land development project. So before they approve, before they give you the approval for these development projects, you have to do a study and you have to tell them what will be the effects of my development on the routes. Okay, and how can I know before constructing the project? I will look at similar data from other projects. So I am constructing a big housing project. So when a big similar housing project was constructed somewhere else, what happened there? So I'll collect data from there and so on. So you need it for that, and obviously when you know how much traffic you generate, then you can use it for estimating air pollution levels as well. Like I mentioned earlier, now this is a big thing. For every project, for every new new work which you are doing, you have to keep the environment in your mind. Okay. And evaluating, evaluating the performance of the facility, which we usually do. Okay, how this highway is doing right now. Right now, what is the delay right now? What is the level of service right now? Okay, so what is the current speed, average speed on the highway, and so on. Okay, so the current condition, the current performance of the highway. The types of studies which we do are these, and we are going to go through each one of them. So let's start with the first one, volume studies. In volume studies, you are counting number of vehicles, number of cars, right? Okay, and volume studies are used as a measure of demand. Okay, the volume which you count, like I said, volume is affected by demand. Okay, the volume studies provide you an indication about the demand because they are like directly proportional, right? So if you are doing any planning for future, you are designing a highway. Okay, you are designing a new traffic control system, a new signal, a new roundabout. Okay, you are doing something with traffic operations. You are going to change the speed limit. Okay, or change the number of lanes, doing something like this. So in all these cases, you need the volume studies. Okay, so I mentioned that they use pneumatic road tubes very commonly in Bahrain. So the pneumatic road tube, the main function is volume studies, the main function. Then we do speed studies as well. The speed is very closely related to safety. So what safety parameter we calculate using the speed? We have done it in the first chapter and the second chapter, the first lecture and the second lecture. What is the thing we calculate which is related to safety and depends upon speed? Stopping side distance or any side distance, right? All side distances depend upon speed. Okay, so speed is very closely related to safety. So whenever we have accident problems somewhere, the first thing which we look for is what was the speed of the road, what was the speed of the drivers, and so on. We do speed studies. Okay, so speed, and it is related to safety in two ways. Maybe the design is not suitable for speed. Okay, so that is causing accidents. So speed can be a cause of the accident, and speed can be a reason of having a severe accident as well. Accidents which happen at low speed are less severe, right? Their damage is less compared to accidents which happen at high speed. So accident can be a cause of accident. Speed can be a cause of accident and can also be the source of having more damage. Okay, so using speed studies, you can revise speed regulations. How much should be the design speed on the highway? How much should be the speed limit? Should we increase it, decrease it? Okay, so these decisions are taken on the basis of speed studies. Travel time studies. Travel time is the one thing or the most important thing for the traveler, right? Whenever you decide anything about your trip, the main thing which you are focusing on is travel time. Now, who came by bus today? Raise your hand. Nobody, right? Why not? Huh? Yeah, of course, obviously. Takes more time. Takes more time, yeah. Okay. You must have taken a certain route when you were coming here, but there are other routes as well. Okay. So why are you going with that highway, not the other highway? Because of travel time. Okay. So how you, and in some cases, we mentioned earlier, sometimes we change the time as well. You come to me with all your different reasons. Okay, doctor, this happened, that happened. I cannot come with this section and that section. But the main reason is, if you are coming from your house just for the lecture, then you will consider how much time is taking. Okay, so the most important parameter for a traveler with regards to his or her trip is the travel time. Okay, your speed is not constant. You are coming from different highways. You just and you may come at different times and so on and so forth, but you are looking at the travel time. Okay, and travel time is dependent upon what? Congestion. How much traffic you have. More traffic, travel time will be high, and so on and so forth. So now, since you are using it, you are using travel time to decide when to go and how to go. Okay, and which route which you take to go. So you are now what? You are part of the demand, right? You are part of the demand. So the demand can increase or decrease because of travel time. If you know I go at this time or from this highway, my travel time will be 50% higher. So you will go some other time or some other highway. So demand reduced. Okay. So that's why when we are calculating the demand for highways or for different modes, different ways of transport, we use travel time as an input. Okay, the mode or the highway which has more travel time will have less demand and vice versa. Okay, what is delay? Somebody define delay.
Congestion.
The time you have in the congestion, okay?
To be late.
To be late.
Extra time than required.
Taking more time than required. Good.
Extra time you take it in traffic.
Extra time which you take in traffic. Okay. So this extra time or being late and so on and so forth. Okay. It depends upon your own perception, right? Okay. So the time during which maybe some of you don't show it from your faces. You are in control, but some of us do. Okay. You start looking like this. This guy. Okay. So when this picture comes in your mind while you are driving, that means you are being delayed. Okay. You are delayed because you have stopped. You are delayed because you are moving slowly. Okay. You are delayed because you are going from another highway which is taking more time because your highway is blocked. All this is part of delay. Okay. And delay is part of travel time, right? Delay is part of travel time. Okay. What part of travel time? The part in which you are feeling that your time is being wasted. Okay. The extra time. Okay. And it can be because of any of these things. But delay only doesn't mean stopping. Keep this in mind. You may be moving and still is part of delay. Okay. Because you are moving slowly than normal, or you're taking another route which you wouldn't have taken. That is also part of delay. Okay. Then we have density studies. Now we discuss something about density. What is density? What is density? Number of vehicles on a section, right? Number of vehicles on a given length of the section. Okay. And he said, what about measuring density? If I ask you to measure density, you will use the equation, right? Okay. Because measuring density at a particular time is very difficult. People not stopping for you. They keep on moving. So how can I know at a particular time how many vehicles are on the length on the section? Okay, so it's very difficult. So we already saw some equations for calculating density in the previous chapter. If you have flow, we have equation between flow and density. If you have speed, you have equation between speed and density. If you have flow and speed both, you have basic equation V equals to S into D. So you can use those equations, or you can use a sensor. Okay, so when we talk about density studies, we're talking about this sensor basically. So we have a detector which is under the surface of the road. What do we call this detector? I just showed it. Point detector. Okay, so this detector itself has a length LD. What is LD? The length of the detector. The length of the detector. Then we have length of the vehicle, which is LV. So density can be calculated using this equation. LV, length of vehicle, average length of vehicle. All vehicles don't have the same length, obviously. LD, length of the detector, which we already know because we put the detector. Okay. Now what is O? O is the percentage of time the detector was under a vehicle. The vehicles are coming and going, right? Okay. So one vehicle came, the next one came after 30 seconds. So for 30 seconds, the detector was unoccupied, right? Okay. So for example, you use the detector for 1 hour. Within that 1 hour, the detector was occupied by vehicles, different vehicles, for 30 minutes. So O will be how much? You did it for 1 hour, and the detector was occupied for 30 minutes. So O is 50% of 0.5. Okay. So O is the percentage of time the detector was occupied by a vehicle. Okay. I just give the example for 1 hour, but it can be any time frame. Okay. So when the detector is occupied, it is telling you that it is occupied for this much time. Okay. So you use O there, and LD and LV are constants. You can get density. Okay. And this equation we are using 5280. So density will be in vehicles per mile. Okay, vehicles per mile, and LD and LV are in feet. Okay. Then we have accident studies. Accident studies focus on characteristics of the accidents. Okay, what characteristics? At what rate the accidents are happening? Accidents per year, accidents per number of vehicles. These are known as accident rates. If you have enough time, we will do this at the end of the course as well, if you have enough time. So accident rates. Okay, how frequently the accidents are happening in terms of time and in terms of traffic. Okay, relationships to causal factors. So accidents happen because of different causes, right? Different reasons. So which causes are more prominent, which causes are less prominent. And locations. Which locations have more accidents as compared to others? We call them black spots. Okay, locations which have very high accidents as compared to other, we call them black spots. So accident studies include all these things, to know all these things. Then we have parking studies. In parking studies, we are trying to find out three things basically: inventory, and duration, and accumulation. Parking studies, we are trying to find out three parameters: parking inventory, parking duration, parking accumulation. Okay, inventory means what? They do inventory for, yeah, good. Inventory means the capacity of the parking area. Very good. Okay, the capacity of the parking area. It depends upon how many spaces you have and the availability of the spaces. Some of the spaces may not be available for everybody. There are some spaces for who? For disabled. Okay, if you go towards the mall or commercial areas, then they have some designated spaces for their trucks as well, where they have to load and unload. Okay, so the number of spaces you have, their arrangement, their availability, so that all comes under inventory. So basically the capacity of the parking area. Duration, you know, right? So it's the average duration of all of us don't park for the same time, right? Our duration is different. I come for the whole day, you come for half an hour and so on, right? So parking duration, average parking duration. And accumulation is number of vehicles at a given time which are occupying the parking area. Okay, accumulation of vehicles at a given time. So maybe capacity of parking area is enough for the whole day. But in the whole day, there's a time, and this is very common for schools. When they have the time for when they are coming to drop off the kids or pick up the kids, the parking area is good enough for the whole day. But in that half an hour in the morning and half an hour in the afternoon, you know. So why? Because we don't have enough parking spaces? No, we have. But the accumulation is very high. If these vehicles were coming in different hours, parking area was enough. Okay, so problem of accumulation. Too many vehicles at the same time. Okay, so these three things are important for any parking study. So through parking study, we try to find out these three things: capacity, average duration, and accumulation of vehicles in the parking area at particular times. In some cases, we may do interview studies to know the behavior of the driver. Why he is coming, why he is parking at this spot, why not some other spot, and so on. Okay, so interview studies are mainly done to know the behavior of the driver. Okay, I will use it for some other study as well, but the main idea of an interview is I know the reasons of your choice. Why you are coming at this time, why you are parking here, okay, why are you parking for so long, and so on and so forth. So for these things we do the interview studies. Goods movement and transit studies. Goods means things, right? So what vehicle we use? To trucks, right? For goods movement we use trucks, and for transit we use, what do we use for transit? Transit means, you know, movement of passengers in large amounts. So we use what? Buses. Okay. So the metro and trains, these are all known as transit. These are all transit vehicles. Okay. So but here buses and trucks, so they are heavy vehicles, right? Both of them are heavy vehicles. Okay. These heavy vehicles can cause a lot of congestion, even if they are in small amount, because they are moving slowly. So they are slowing down everybody, and you have to keep more distance. They take more space to turn, and so on and so forth. Okay, they cannot accelerate that much as compared to a car, so they slow down everybody. So even if they are like 5 or 6% in the traffic, their effect is more than having 10% cars or 20% cars. Okay, so because of this effect, we do transit and goods movement studies to know their percentages, the percentages of heavy vehicles, which route they are taking, what time they are going, and so on and so forth. And then we plan accordingly. On certain highways, trucks or buses are not allowed. There are certain times in which trucks and buses are not allowed at certain highways. Okay, I haven't seen it here, but in some other countries they do that. From this time to this time on this highway, no trucks and buses, no truck or buses allowed. Okay, even sometimes they control it through the port area. Okay, so they will ask them, okay, now for this time you will not do any dispatch for the trucks. Okay, the truck is ready, but you are not allowed to go now. you stay here. Okay. So in Pakistan, I remember when we were there. So some of the truck drivers, they finish their trip now, and then they are allowed to go after 12 hours. So they have to spend those 12 hours there, in the truck or in the port area. Okay, so 12 hours they will do nothing. Okay, so okay, pedestrians, as I mentioned earlier, they are part of the traffic demand because of the new purview, right? We have to include all modes of transportation. So they are also part of the traffic demand, and basically we have to take care about their crossings. Okay, so sometimes we do pedestrian demand studies to know how many pedestrians are crossing, from which place they are crossing. Okay, and then there is another important parameter, which is their walking speed. Okay, so even to know their walking speed, we need some studies. Okay, we may include interview studies for pedestrians as well. Okay, what's the reason of these interview studies? I told you, to know the behavior, why they are crossing from here. Okay, and from why not from some other place? If you build a bridge, will you use it, and so on and so forth. Okay. Calibration I already talked about, right? What was calibration? Quickly. Calibration was what? I remember something. This is calibration. Driving these equations was calibration. So to do calibration, we said we need what? We need data so that we can plot and we can see how the relationship is going on, linear or curve or what. Okay. Observation studies to know the effectiveness of the improvement. Already talked about it, right? I made some improvement, put a new signal. I do a what do they call it? I gave it another name. Follow-up study. The follow-up study, observation study, same. Okay. Any questions? Okay. Thursday you have the quiz. You will come in at your own section's time. Okay. You can do the quiz. It will be online. Okay. But you have to be in the class. If you are not in the class and I see your attempt, I will make it 0. Okay. You have to come to the class. You can do it on your laptop or tablet or mobile, whatever. Clear? Okay. But in your own section's time. I cannot open the quiz for both sections at the same time. I cannot do it. Okay. Thank you.
No, you take that in here? You take that in there?
No, today no. Because you came early, so I'm not taking it.
There you have for section 2 cancel.
Cancel.
Lucky application. I tried to register with my student account, but it cannot be the verification for the email. I cannot get it. So I registered with my normal email, the Gmail. It's good.
And you can still access the software?
Yes. But my student, I already.
You can still access the software.
Yes.
And you can download it, you can learn it, and so on.
Also, for the complete, you want us to download another software.
Okay.
But
If it works, fine. If it works, fine. Yeah. Okay. But the software, the certificate will have your name. The profile should have your name. Okay. The name, the official name.
بس دور الرجل كان بيوصل
بس اقول لك حاجه الدوام كده
هو كان خبري بس
الكنسل ما شغال يوم واحد
هو دوار
انا الماتش اللي زحمه
صح